Hello everyone. Am I audible to all of you?
Yes, sir.
Okay. Yeah, you can call me by name. So, I am the TA, one of the TA of this course. Basically, uh, I will be uh, I will be taking a live session each weekend for all of you, where I will be solving some of the previous year assignment questions, so that you can also get idea what kind of questions you will get in this year assignments, and how to how to go for it. You will find easier to solve them after attending these sessions. So I am research scholar at IIT Madras in the Department of Mechanical Engineering. So where all of you from? Someone can unmute and tell about himself or herself. So I can see there are seven people are here. So still I will wait for 5 more minutes to others to join. Meanwhile, if someone can unmute himself or herself, and they can tell about them, what kind of expectations they are having from this course, and what they are doing where and from where they are attending this course. If anyone wants to ask something, please feel free. Please don't hesitate. So whatever doubts comes in between, please don't hesitate. Stop me in between and let it be clear, and then we can move forward. So we just treat like friends. We are all here to discuss our assignments here. So please be frank, and I would happy if it would be very interactive session, so that all of could get benefited maximum out of it.
Hi, good evening. I'm Narottam here.
Hello, Nantam,
Hi.
how are
I
you?
joined this course from Abu Dhabi.
Okay, thank you so
Actually,
much.
I'm working in the industry. I'm doing this course for get my credit because I joined in a PhD course where we need some credit.
Okay,
So that's why I joined this course, and I attended 2 3 classes. But I would just would like to know. So in the assignment, what are the procedures? Because what is the time durations and how many questions are there? But till now I didn't start my assignment. I would like to know about the assignment.
okay. If you have visited the course page, then each week you will be getting the links for the lectures as well as the assignments, and you can attend the assignments whenever you want, but there is a timeline. Before that you have to submit in order to get it evaluated. The type of questions will be mostly the objective types, where there will be one correct answer, and you had to attend. It will be easy for you if you could, if you go to the assignment after attending the lectures. So basically they will be mainly from the lectures itself. If you have attended all the lectures, then you can easily go for it.
But my question is, means if the assignment is 10 to 15 questions, so within any time period we need to finish, or we can refer the presentation, other thing, and finish that one.
No, there will be overall on the on the each assignment page. You can also find the what would be the last date before you have to submit it. So you have to finish it before itself, because at the end of this course you have to give a final examination in order to get certification. So before that timeline you have to finish all the assignments. So it will be better if you could find time to finish within each week itself. After attending lectures, you should attempt the assignment immediately. It will be very beneficial for
So
you.
that should be sorry to interrupt you.
Yes,
That
yes,
should
yes.
be one attempt, or we can do several attempt to finish the assignment.
No, no, no. Only one attempt before final, before submitting. You will get only one chance to submit it. Once it gets submitted, then it will consider for the evaluation. So there
No,
will.
once I open this assignment, I need to finish and submit immediately. That is the
No, it is
procedure.
not like that. If you are not confident, don't submit. You can see the questions. You can take your time to solve it, and after that again you can come, and when you are satisfied with all the answers, then put the submit button.
Yeah, yeah, that is. Thank you. That I want to know.
Okay, okay,
Thank
okay.
you.
Thank you so much. Okay, I think now we should start. So I will start presenting. Whether my slide is visible to all of you?
Yes, it is visible.
Okay, okay. Thank you so much. So, welcome you all to the very first live session on the course Fundamental of Manufacturing Process. So, this is the first week, and here we will be solving the assignment 1 of the previous year questions. So, course instructor is Dr. Professor D.K. Dwivedi. He is the professor at the IIT Roorkee, and I am a research scholar at IIT Madras in the Department of Mechanical Engineering. So let's start with the first question. Please take a minute to read the question and let me know if you find difficulty to understand the question. So whether where any of you have any difficulty to understand the question, please unmute yourself. Otherwise just know the answer, but don't tell me now. So let's go one by one. So whether all of you aware of the term advanced materials? Hello.
Yes, sir.
Okay. So those who don't know what are the advanced material, so this is the definition of advanced material. So they are nothing but they are traditional materials, but they are engineered or modified in such a way so that their performance is improved and they can use for very specific applications. So this is the definition of the advanced materials. So can anyone of you can give some examples if he would have come across to this term, what are the advanced material? Any example of the advanced material?
Superalloys.
Yes, correct. Anyone else? Yes, correct. Carbon fiber. Yes. So yes, both of you are correct. Superalloys, carbon fiber. So these are the advanced material, and also they are also known as the material of the future, because they are going to be used in future technologies. Like I will like to give some more examples, like smart material, nano engineered materials. So these are the few examples. So let's start looking at the options. Yes.
Excuse me, this you are going to share this recording, or we are allowed to record this?
Yeah, if you want, you can record this. Also, you will be getting the YouTube link for whole session.
So in this NPTEL link, right?
Yes.
We will receive this link for the recording.
You will receive the YouTube link of this recording. So if you want, you can record also.
Okay, thank you. If you receive, okay, that's fine.
Yes. So before that, I think many of you have got the answers, but still please don't tell. I will start a poll where you can select your options, whether I want to know how many of you have got the correct answer. So I am creating a poll. Yes, you might have received a poll in activities section. If you see in the Google Meet below, you can find activities. Okay, still few people are yet to. Okay, I got 4 responses. Yes.
Excuse me, where we get this? I'm not getting the activity.
Are you attending it from the laptop or
Yeah,
mobile?
yeah, I'm attending from laptop.
Okay. Uh, can you see at the bottom right corner? Can you see?
Yeah, there is
There,
a number
there
of
is
attendees and there is a
last
meeting
second option.
activities. Yeah.
Yes. Did you got it?
Yes, yes.
Okay.
Thank
Okay.
you.
Okay. Okay. Then you can send your response.
Yeah.
Okay. So there are. So if there are still few people are yet to respond, but all of who have answered all are correct. So it is the third option, aerospace and nuclear reactors. So let us talk about in which part of the aerospace what kind of material is being used. So just I have displayed a diagram which is of Boeing 787 aircraft. So we can see there is a huge percentage of use of composites. And if you talk about like steel, which is a conventional material, it is not an advanced material, its application is only 10%. And whereas the composites, aluminum, titanium, they are having the significant uses in the different parts of the aircraft components. Why it is so means some of you can tell why these composites are getting much more attention for the aircraft industries. Can you think of? Okay. I assume all of you know, but still it's only because of aircraft industry is mainly interested for the lightweight materials, lightweight high strength materials, and we the composites are the material where we can engineer them in such a way so that its weight will not go so much high, as well as we are able to get very high strength for these materials. So that is the reason. Now if we see about the nuclear reactor, so what happens in the nuclear reactor? We are using the nuclear reactors for producing the power, and power is basically produced by turbine blades. And turbine blades where are turbine blades are keep on running at high temperature for very long duration of time. Sometimes they keep on running throughout the year and at very elevated temperatures above 100 degrees Celsius. So normal materials, conventional materials are not able to survive that kind of harsh temperatures. So we need advanced materials which can serve our purpose. So nickel based super alloys, titanium alloys, and composite some part composite materials are also used. But if we see the rear section of an turbine, so this is made up of nickel based super alloys. So these are the kind of specific applications where our conventional materials will not work, and therefore we use advanced materials. So I think this question is clear. Any of you have any doubt, please ask me, so that after that we will move to the next question. Am I clear to all of you? Or if you have any doubt, please feel free to ask me. Okay, hopefully all of you have understood the question. So this is the correct option. So this is the second problem. Please read it. This is the second problem. Please go through it, and again I will create a poll and please answer it. Yes, Kundan, you can give your answer to the polls. Although you are correct, but you can again give your answer in the polling section next time and onwards. Yes, most of all of you are almost correct except one person. Okay, let's discuss it one by one. So we are trying to develop the new manufacturing technologies, so it's very obvious. We definitely want to reduce the manpower. We want to most of the things get become automated, or they will ease the effort of the human. So first option will not be correct. So increasing the number of resources, we know that uh, we number of resources are it is very fixed. Like we have limited fossil fuels, we are getting solar energy, which is already means fixed. It can't be increased by increasing the developing the new manufacturing technologies. So that will not be a very accurate answer for this. Let's go for the third option, increasing the production time. It is not at all desired. It is very obvious. So every time we want higher rate of productivity, we want produce as we want component get produced in very less amount of time. So that is also a wrong answer. And increasing the productivity and the quality of the product, yes, that is the correct option, because we want to produce larger amount of products in very less amount of time without compromising the quality. So fourth one will be the correct option. Let's move to the next question. So if any of you have any doubt, please feel free to ask me. Again, please take a minute to read the question and answer it only in the polling section. So polls are live. Please go to the polling section and give your answers.
So where can I find the option to give my reply on poll? I'm not understanding that.
Are you using your phone or desktop?
No, I'm using my phone.
Okay, so you must find an icon with triangle, square and circle.
Which
Activities section. Basically you will find option of activities, participant chat activities.
activities? Yes, yes, activities there is.
Yes,
Oh,
yes,
so, okay, thank you, sir.
yes, 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 yes,
Okay.
yes. Polls are
Where?
active.
Thank you.
Okay, okay, okay. Okay, most of you are correct, but still few people have given wrong answer. Let's see. So if all of you have gone through the lecture or according to your previous knowledge, uh, can you tell where the finishing process is used, or it is comes in under which category of manufacturing process the finishing process comes? Yeah, actually I want to ask, um, like you have if you have gone through the lectures, you have seen different kind of operations which are talked by this, like casting, forming, machining. So so I was asking about finishing process comes under which category? Yes, 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 yes. Honing, lapping, buffing. So all of these are examples of the finishing process. Thank you, Hardik. Thank you so much. So honing is a kind of finishing process which is used to get the very good surface finish. Usually what happens, uh, we have some component, we get it from the casting. After that it has lots of uh, surface irregularities, dimensional error. Then it goes for the machining process like turning, milling, drilling, and at last, in order to get the desired surface roughness, we go it for the finishing process. And honing is the one of the process of the which comes under the finishing process. So let's join it. Okay, now coming to the metal removal process. So metal removal process, basically it comes under machining. Here after machining it comes finishing. So after casting, the component which we get, it doesn't have its correct dimensional accuracy. So what the next process which we go for the machining, in order to like this is the final component size which we intended to get at the end, but uh, in the casting process deliberately we give some tolerance for the machining, so that after casting we will the component we go for the machining, and there is some finishing tolerances also given. So what happens, some extra material, these are the some extra materials which gets removed during the machining process. So uh, that's why it is called a metal removal process. And turning is the one of the process. Turning is the process which is, suppose we have cylindrical rod and we want to reduce its diameter. Let's say this one is the final diameter. What we do, we take this rod, we will take this rod and with the help of lathe machine we will try to reduce its dimension. Basically what happens, this is the workpiece or rod, this is the tool, and with the help of tool on the lathe machine we try to remove the material which is extra, and we want to get the component which has dimension which is intended. So a rotation motion is given to the rod and a linear feed motion given to the this tool, and with the combination of these two motions we are trying to remove the material. So that is the turning process. So metal removal will be a turning process. Coming to the third option, material property improvement. So what happens when we get suppose we got a component after casting and we did some machining also, but still it doesn't have desired property. Desired property means, let's say, its toughness or its strength. So toughness and strength, so these two properties we can improve even after components get manufactured with the help of some processes which is called the improvement processes. So I will not go in details processes now. You will find these things in very detail in this lecture series. So I will just give the names of those processes. Carburizing process, normalizing, annealing, tempering. So all these are the names of the process which is used for the improvement in properties of the component which we have manufactured. Basically it will alter the toughness and strength of the material. So normalizing will be the correct answer for the third one. And joining, if you all have gone through the video lectures of the course, then you must have find that there are processes which comes under the joining. We have welding, we have soldering, bracing as well as the adhesive joint. So bracing is the one of the options which we are finding here. So this will be the correct match, and if you see which option is that, first C, second D, third A, fourth B. Okay, the first one. So whether it is clear to all of you? If anyone have doubt, please ask, or I shall move to next question. Okay, no one have doubts, so let's move to the next question. Please read the problem and answer in the polling section. Meanwhile, I am creating the polls. Yeah, polls are live. If you have got the correct answers, please answer in the polling section. Okay, I will give you half a minute more. Okay, this time I have got very mixed response, so hopefully you can also see. Okay, let's discuss. What are the forming processes? So we have, if you everybody have gone through the video lectures, then one thing is clear, that the forming processes are the processes where some force is required. Hello? Yes, anyone have doubt? Okay. Okay. Yes, I was telling. Forming processes are the process where we require some force, and we try to deform the shape of the material. We have raw material, but it is not in the form or in the shape of which we needed, so we have to do some operations on the material so that its shape should come in our required, so that it could get the shape of which we required. So one of the example I wanted to show you. Let's we have rolling. Let's talk about the rolling operation. Do any of you have idea? Can you give some examples which are made from the rolling operation? you can write in the chat, or you can unmute yourself. You can tell, can you tell some components which is which we can get from the rolling operations? Correct, sheet metals, coils. Okay. Yes. Yes, apart from that, all of you have definitely seen railway tracks. Yes, metal bars, correct. So railway tracks, they are made from the rolling operations, or there are slabs, uh, billet, all those things are there. But final thing which you must have all definitely seen, that is the railway tracks. But other things are also produced from the rolling operations, but they are not directly come to the use of the final use for the to the customers, like slab and sheets. These are the product which we get from the rolling operations, and they are called the wrought products, and they are used for they are the product for the other industries, like car industries or aircraft industries. So that will the product for them, but not for the end users. So how it happens? Suppose initially we have a block like this, and we want okay, we want a sheet which has different thickness. Okay, this is the initial, and this is one is the final. So what we can see, the total amount of material which we have, it's fixed, and only the shape is going to change, and here the cross-sectional area has been changed. So how it is possible? It is possible, admit. Okay, what we will do, we will try to compress the material from the top and the bottom in such a way so that it will take the shape of final form of sheet which I have drawn below. So, but how it can be done? So it is done in the rolling process like this. We try to pass our block from in between the two rollers, and we try to put forces, compressive forces on the material, and we are expecting the thickness. Initially it has thickness T1, and finally it has thickness T2. So we want to reduce the thickness from T1 to T2 with the application of the force. So we apply force, and the thickness of material get reduced. How it has happened? What happened? The material has deformed plastically. Plastic deformation means once it get deformed, it won't, the shape will remain as it is. It will not change to the initial one. Let's talk about with the help of stress strain diagram. What is what is the plastic deformation? Plastic deformation is a permanent deformation, but I am going to draw a stress strain diagram for any typical material, let's say a metallic material, and we want to see uh, what is the yield strength and ductility from the help of the stress strain diagram. Typically this is the stress strain diagram. It is of the ferrous material, but likewise you can also get stress strain diagram for the other materials. So what does this diagram shows? It shows, suppose we have initial material and we are applying a load F. What will happen if we apply very less load? Will it deform? Yes, you can give your answer in the chat. If we apply a very less amount of load, whether we will able to deform a material. Let's say this is a steel. So on very less load, it will, yes, correct. It won't deform. But what will happen if we keep on increasing the force? Yes, if we keep on increasing the force, if we increase the force little bit, then it will deform. It will deform very little, but that would not be a permanent deformation. This deformation will be similar to the like rubber band, like how much till the time we have applied the load, it will deform little. Basically it will get elongated little bit, but when we release the load, again it will come to its original shape, and that's called the elastic property or the elasticity of the material. So that's what happened in these region. So if we are applying the load, basically here I have shown the stress, and this is one is the strain. Stress is nothing but force upon area. Strain is nothing but change in length upon, I am talking about the engineering stress strain, change in length upon original length. So on applying a little force, little elongation will happen somewhere. If you see in this region, we applied a force which is not capable to deform it plastically, but some elongation will happen. But once we remove the force, it will regain its shape. So this is the reason where no permanent deformation will happen. So here we are increasing the load in this direction, but after a certain point, if we further increase the load, what will happen? This material will get deformed, but it will be the permanent deform. it will not come to its original shape again. So basically this is the point. For all material there is a certain limit. After that limit, if we further apply increase the force or stress, then material will start deforming the plastically, or we can say permanent deformation starts happening, and that point is called the yield point or the yield strength. Correct. And let's talk little bit about ductility. Ductility is nothing qualitatively. It is defined as it's the ability of the material to get deformed plastically without fracturing. So I will repeat again. Ductility is defined as the ability of the material to get deformed plastically without getting fractured. But how mathematically it is defined? It is defined as by percentage elongation, which is equals to LF minus L0 upon L0 into 100. Suppose initially we has the component size of L0. Initially we have size of the component L0, but when it's deformed, okay, this diagram is not looking good, so I will redraw here again. Okay, this is the final length of the material, which was initially L0, but we applied force and final its length become LF. So now ductility is defined by the percentage elongation, which is the LF minus L0 upon L0 into 100, or change in length divided by initial length into 100. That is defined as the ductility. Now let's come to the question. High ductility and low yield strength, low ductility, high ultimate strength. So likewise that. So our aim was to deform a material into desired shape permanently. So being a user, I want to put very less effort, as much as less I can. So basically I want to do something by putting very less effort. So a material which have low yield strength, so we have to, if a material have low yield strength, we have to apply very less force to deform it plastically. And if a material is ductile means if after applying a very less force, material is deforming plastically by large amount, that will be the more ductile material. if the ductility is high, then by applying less force we can deform the material in very large amount. Force requirement will be the less, but we have high if we have low yield strength. If material have low yield strength, then again force requirement will be the smaller. So being a user, I definitely want to transform this material to this by applying very less force, and that can be possible only if ductility is higher and yield strength is low. So that's why option 1 will be the correct option. So this was all about the problem number 4. If any one of you have doubt, please feel free to unmute yourself and ask me the question. If any point I am not clear, please ask me.
It is also related to the temperature, right?
Correct.
So here what we are discussing all is about the hot rolling or cold rolling.
So whatever, if we do about hot or cold, if material is more ductile, it will require less force, and if its yield strength will be the low, then again it will require the less effort to roll the material. So temperature, if we rule out temperature factor just based on the ductility and the yield strength, that has been talked about in the whole question. We are yes, it is true for the both, whether hot rolling or the cold rolling. So this will be true. Anyone else? So if anyone have no more doubt, then I will try to move to the next question. You can ask even later if you find some difficulty in understanding anywhere. So I am going to the next question. Please take a minute to look this question and try to answer. Yeah, polls are live, so please use the polls to give your answers. Yeah, I have got still many people are waiting, so please take your time. Yeah, I have again got some mixed kind of responses, but majority of them are correct. So let's start discussing about this question. If you can remember, then I can quickly summarize the what is the casting process. If you have gone through the lecture, then you could easily get it. So I will try to draw the some schematics of the casting, which already I have also using the same schematics which already has been presented by the professor in the lecture. So what happens initially, we have raw materials, and we have raw material something like that in the form of scrap or any arbitrary shape, and finally we want to get some shape like this. Then I will explain how it has been done via casting route. So we have raw materials, we try to heat inside a furnace. Basically we try to heat the material till it gets melted. So earlier they has shape of some arbitrary shape, block like shape. They were in the solid form, but after heating sufficiently, it has been converted into the molten shape, molten form. And we want to pour this molten material inside a mold which have the shape of our intended product, the final shape, this one. So let's for now just assume our mold is like that, and let us assume that this whole mold has been made by the sand. So we have this mold, and we try to pour this metal inside the mold, and we give some time to get it solidified. And after some time, when whole molten metal gets solidified, then we can get the final shape like this by removing the mold, by separating the mold from the solidified material. So this was the whole process of the casting. Now let's go and see what are the options are there. So first option is the ability to produce products of complex geometries. Yes, it is correct, because suppose I would like to show by some examples, like here. Okay, these are not visible. Okay, and what I will do, I will remove the diagram. Okay, so this is the whole casting process. Please glance it once. Yes, please glance it once, so that I can show to you what are the different kinds of things, what are different kind of geometry which are made from the casting process. So these are all the components. These are the different components of the different machineries or automotive engines. So these are all made from the casting process. So these shapes are not very simple shapes. They are very complex shape where there is a lot of integrated features are there. So these all are made from the casting. So first option is correct, that casting process have capability to produce the complex geometry. Now coming to the second option, high melting temperature metal can be fabricated easily. Since we saw first we had material and we tried to melt it by heating. Suppose what will happen if the melting point of raw material will be very high. If melting point of raw material will be very high, then we have to heat it a lot, or we have to give lots of energy in order to just to melt the material. So in that case, that process will become very costly. It will not be economical at all. Therefore, we are looking for a material which could get melted easily by providing very less amount of heat energy. So it will happen only when if the melting point of material will remain low as possible. If we talk about ferrous materials, then cast iron have relatively less melting point compared to the mild steel, or let's say high carbon steel, or the stainless steel. So here aluminum, if we talk about the aluminum, the melting point is near about 660 degrees Celsius. If we talk about magnesium, melting point is 650 degrees Celsius. If we talk about iron, here melting point is above 1500 degrees Celsius. And let's say if we talk about tungsten, then melting point is above 3400 degrees Celsius. So according to you, we should, if we have tungsten, should the casting will be the good process? Please write in the chat. If we have, let's say, tungsten, or if we have some ceramic material where the melting point is greater than 2000 degrees Celsius. So whether if you want to manufacture some component from the tungsten material or the ceramic material, should we go for the casting? Yes, no, because they have the melting point is too high to melt, and it will require lots of energy, lots of costly equipment to melt it. So second option, if we check high melting point temperature metals, so it will not be a correct option, it will be the wrong. Now come to the third option, suitable for both batch and mass production. If you know batch and mass production, I will tell you briefly. Batch production is something like where the small batches are manufactured in a one time, like let's say 20, a batch of 20, a batch of 30. So components get manufactured in batches, whereas in the mass production the very high quantity of components are manufactured, more than 1000, 5000. So this process can be used for any kind of production, whether it is batch production or mass production. If we have we can make large number of molds, then we can, in order to produce the large many components at a time. Also there is a process which is called continuous casting, where we keep on supplying the molten metal, and casting will keep on happening simultaneously. So that is used for the mass production in the industries. So this process is suitable for the both batch as well as the mass production. And let's come to the fourth option, free from internal and external defects. As I have shown in the diagram, we try to pour the metal inside the mold. And this mold is made up of sand. And after the solidification, we get some component like this. If you have gone through the lectures, then sir have explained there are many defects, internal as well as the external defect, which present in the cast product. It happens because any material it has different capability of solving gases inside it, in the molten state and in the solid state. There is a tendency of, if a material is in the liquid form, then its solubility is higher. It means if material is in the liquid form, then lots of atmospheric gases will get, or I should make it a little bigger. If we leave any molten metal, then what will happen? All the different gases, nitrogen, oxygen, hydrogen, all the atmospheric gases will try to get dissolved in the molten material. So at high temperature or in the molten form, it will absorb lot amount of gases. But when we pour this material inside the mold and we lift it for the solidification, then what will happen? As temperature keeps on decreasing, the solubility of these gases will keep on decreasing. As the material starts solidifying, the gases which already has been absorbed in the molten form try to come out of this molten pool. Here solidification starts, gas will try to escape here, 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 here. So if now if our mold doesn't have good permeability, then what will happen? Then it will not allow two gases to come out from the molten metal, and because of that the gases will remain trapped inside the material itself and even in the solidified form. Although material has been solidified, but gases which it has already absorbed at the high temperature were not able to escape because of poor permeability of the mold, which was made up of sand. Therefore these air or the gases bubbles will remain entrapped inside the material, and this is called the defects. And similarly, external defects will also be present, and which there is a separate lecture for the casting defects, which will be taught in the later in this course. So there sir will discuss more about it, but definitely this option is not correct, because casting products have internal as well as external defects both. Therefore the correct option will be which having first and third, so second. So whether this question whether I am clear, or if any one of you have doubt, please feel free. So second option is the correct option. If no one has doubt, then we can move to the next question. Please take a minute to read the question, and meanwhile I will create the polls. Yes, I have launched the polls. Please give your responses in the polling section. Basically, this question is asking about comparison between the forming process and the machining process. So if you have gone through the lectures, then it will be easier for you to answer. Okay, only very few people have given their response. Okay, I will wait for 30 more minutes, 30 more seconds. Yeah, everyone can try. Okay. Okay, unfortunately this time no one has got the correct answer. So let us discuss one by one. Yeah, here this question is all about the advantages of machining process over forming process. So here first one is the high production rate. Let's make a column for machining. And forming. Production rate is in the machining process is not too high. If you have come across to the any workshop or any machining shop, then you must definitely have seen that it takes a long time to produce just one component from the machining process. Suppose we have a simple block like this and we want to make many features there, like here hole, here boss, or some circular geometry. So likewise that I will show some examples like here. These are all the components made up from the machining processes. So suppose if you are taking just this component, how it would have been manufactured. If you take this component, then initially we must have our raw stock material, something like that, some cylindrical shape, and from this cylindrical shape we are manufacturing this very difficult shape. And how it has been happened. So what happens, this has been done by the end milling process, which is a part of the machining process. What happens, there is a vertical tool, it comes to the workpiece, and it tries to remove the material one by one, and it tries to remove the material layer by layer in order to bring this cylindrical block into this very complex shape. So what happens, it will take lots of time to make this component from this machining process. But if we talk about the forming process, then it is very fast process. Basically, if we talk about rolling process or extrusion process, there what happens, the production rate is very very higher. That's why all the forming processes are used by the industries for the mass productions. So this is the extrusion process, this is the rolling process. It happens because there is continuous, roller keeps on rotating and we keep on supplying the material continuously, and we will getting the component at very faster speed, sometime 1 to 2 meter per second. This much of speed we get from the forming processes, but that kind of faster process and that kind of speed we can't achieve for the machining, because that is the precision process and it takes time to remove the material layer by layer. So if you are comparing these two processes, then definitely the forming processes are very faster, and that's why they are used for the mass production in the industries. So the first one will not be the correct option, and if we go for the second option, very good surface finish, yes, it's correct. Machining process, from the machining process it's used to get the good dimensional accuracy as well as the surface roughness, so that is the correct option. So machined component, they are the final product, and that has very good surface finish, so this option is correct. High aspect ratio features, so this is kind of little bit confusing option, which requires little bit understanding. Basically, if we see these components, we are getting aspect ratio means length into width into, or length into breadth into height, or length into width into height. So aspect ratio is higher when, like, when it has 1 1 1, the ratio is near about the 1. For the forming process, this ratio can't be achieved because uh, when we go for the rolling, then we get a component which is higher in length and very less in thickness. So here the aspect ratio is not very high. But if we go for the machining, like if you see this component, this has roughly this this have relatively good aspect ratio, the ratio between length, width and height. So this is produced by the machining process, but this kind of components can't be manufactured with the help of the forming process. So with the help of forming process, there should be uh, uh, either length will be too high or high, or the thickness will be the too low, or width breadth will be the high, so something like that. But you will not get a component from the forming process which will have 1:1, near about 1:1:1 ratio between length into breadth into height. So that's why this option is correct. From the machining we can get a component which has good high aspect ratio features. And coming to the fourth option, as from the figure itself, it is very clear that these kind of complex shapes are made from the machining processes, and by any forming process we cannot manufacture this component from this cylindrical block. So complex shapes can be made from the machining processes. That's why which option is correct? Third, second, third and fourth. Okay, this fourth one is the correct. Now is it clear to all of you, or still it is unclear to few of you? So no responses are there, so I assume that all of you have understood. The fourth one is the correct option. Now this is the kind of theoretical problem directly from the lecture. So CAD CAM and rapid typing principles are mainly used in. So if we talk about what are the CAD CAM and prototyping principles. CAD CAM is the computer aided design and computer aided manufacturing. So that is the full form of the CAD and CAM. And rapid prototyping principle means this we are trying to manufacture a component not for the final use, it is just for the prototype. Suppose prototype means, if suppose we have designed some product and we want to check the functionality of the product, then we don't go directly for the final production. We just make a prototype of it and then we try to see how whether it is up to the mark, whether its functionality is good. So that kind of things are there under prototyping principles. So let's talk about the options. Forging process, it is highly used by the industries for the mass production or the final production of the process, and that doesn't require any CAD CAM or programming. So forging is mostly done by them manually, so that's why the forging process doesn't involve CAD CAM or prototyping principles. Likewise, casting casting also doesn't requires any programming. It is again or the automated by the machines, or it is done by manually. So here the use of computer is very minimal for the casting as well as the forging process. Coming to the welding process, uh, if you in if you talk about the conventional welding techniques, they are mostly done by manually, like gas welding, TIG welding, MIG welding. So all are mostly done by manually, uh, but still now there are several welding techniques like resistance welding, spot welding. Those are controlled by the computer programming. But still, here comes the prototyping principles. So welding techniques are not not have been much used in the prototyping principles. So although some part of has been of welding and so for some applications welding is done with the help of the computer programs, but they are not used for the prototyping principles. So that's why welding will also be the wrong option. Coming to the regenerative processes, it's one of the process which comes under the regenerative process is like 3D printing. So what happens in the 3D printing, we manufacture a component just by depositing one layer over each other. And this is totally done with the help of the computer. What we do on computer, we create the solid model of the material, and with the help of programming, basically there are the slicing algorithm. So they divide the solid components into the layer by layer, and finally there is the 3D printer which takes the raw material and it deposits the raw material layer by layer in order to form the final product, which is like that. So this is the process how the 3D printing works, and it involves both CAD, CAM, and it is highly being used for the prototyping applications. Like industries use this 3D printing techniques just to check how whether the functionality or the aesthetic wise or design wise the component is looking good or not. So that is highly being used for the prototyping. That's why this regenerative process is the correct answer. Now coming to the problem number 8. Okay, I will create a poll for this. Please go through the question, and meanwhile I will create the poll and give your responses. Yeah, polls are live. So till now I have got just once response. Okay. Okay, take 30 more seconds. Who are still trying to solve the problem? Okay. Okay, most of you have given the answers, but only one person is correct. So let's see how it goes. So this is problem all about the machining process. So again I will just make a rough diagram of what happens in the machining. We have machining is defined as removal of material. Although these things will be taught later in the course, but still just for the introduction purpose, and this problem has been given to you just to make your little understanding of the machining process. But later on this course it will be explained by the professor in very details. So I will just, keeping this question in mind, I will try to explain the process. Oh, machining is the removal of material. So let's say earlier we had a rod like this, and we want to manufacture a component like this from the rod. So what we have to do, we have to remove these materials in order to get this final product. So how this material is get removed? This is removed with the help of a cutting tool. This is tool, this is workpiece, and we are trying to remove some unwanted materials from the workpiece with the help of tool. Here we can see the interaction of tool and workpiece is happening. Then who will decide that whether tool will remove material from the workpiece or workpiece will remove material from the tool? So can you think of, we have workpiece and tool, they are interacting, but at this point of time we are not clear whether workpiece will remove some material from the tool or tool will remove some material from the workpiece. So can you unmute yourself, or you can type your answer in the chat box. How this thing will get decided, which will remove which? Yes, your answer is right, Naga Srinivas. Tool will remove the material, but how did you come to know?
High strength.
Yes, high strength, correct. Basically, yes, you, anyone else? Okay, if anyone else want to talk, please unmute yourself and you can talk. Okay. Okay, then I will explain. Basically, the strength of the tool material. oh, Okay, strength of the tool material is higher. Strength of tool material is higher than the workpiece material. Since it is stronger, then definitely it is going to remove the material from the workpiece. For example, tool is made up of let's say high speed steel HSS, high speed steel, and this workpiece is made up of aluminum. If we talk about the yield strength of HSS, then it is roughly above the 210 gigapascals. And if we talk about the yield strength of aluminum, then it is roughly sorry, it's not the gigapascal, sorry, this is wrong. Yield strength is near about the 450 megapascal MPa, and yield strength of aluminum is near about somewhere between 70 to 100 megapascal. So since yield strength of workpiece is very low then definitely tool is going to remove the material from the workpiece. So let's come to the option. First option is high hardness of the workpiece. No, if workpiece will be the harder, then it will very difficult to remove material from the workpiece by the tool. This will not be the correct option. High strength of tool, yes, it is correct. If tool strength will be higher, then only it will remove the material from the workpiece. High interaction of work tool during machining. So this third option, it is talking about the interaction of work tool. Work means workpiece, tool means tool. What happens during the machining when this tool, basically what happens, this workpiece keeps on rotating at very high RPM, and at that and tool comes to the workpiece, and as soon as it's gets contact, as soon as contacts gets established between the tool and the workpiece, then lots of heat is getting produced because of the friction. Since its workpiece is rotating at very high RPM and tool comes into the contact of the workpiece, and because of friction lots of heat is getting produced. So since when the heat is produced, then it will try to increase the temperature of tool as well as the workpiece. Temperature becomes higher for both workpiece as well as the tool, and we know if two things are brought in the contact at the high temperature, then there is possibility of uh, joining or sticking. At the high temperatures, since uh, tool and workpiece both comes into the contact, and because of high temperature there is adhesion process starts happening between the tool and the workpiece. And because of this, the process of cutting becomes difficult, and that cause the different kind of problems which will be talked in the lecture, like built-up edge formation or wear. Because of interaction of tool with the workpiece at the high temperature, some part of tool will get wear out as time passes. So then what will happen? Our tool will not remain sharp. Some material has been removed from the tool and it will become weak, and cutting process will become very difficult with a blunt tool. So if interaction will be high, then machining process will not be easy, it will difficult. So that option is wrong. Since first and third are wrong, fourth will also be wrong, that is all of above. That's why only second option is correct. So it is clear to all of you, or you have doubts? If you have doubt, then you can unmute yourself and you can ask me. Okay, I think everyone has understood the problem and its solution. So let's move to the last problem. Okay, I will create a poll. Please take a minute to read and understand the problem and give your answer on the polls. Yeah, polls are live. Okay, I have got the 4 responses. I am looking for a few more. Okay, I have got the responses. So yeah, majority of you are correct. Okay. Okay, I will explain this problem and very briefly. Basically, it is the question which is directly taken from the lecture 5 of the first week. So why there is a need of classification of the manufacturing processes? So if you have gone through the lecture, then manufacturing processes has been classified into uh, into many different uh, based it has been classified into different categories on different bases. On different bases it has been classified into different categories. So coming to the first option, by manufacturing process has been classified into casting process, forming process, joining process, casting, forming, joining, machining, yes. So what are its advantages? If we talk about the better segregation of processes based on fundamentals. So fundamentals means uh, we can all these processes, all these broad categories of processes are based on very fundamental physical concepts of the physics, like casting. Here melting of material is involved. Forming, force, application of force comes under the forming. Joining, here two materials get joined. Machining, material removal takes place in machining. So these are the some fundamental things which on the basis of which these processes has been defined. So based on these fundamental properties of the manufacturing process, they can be segregated into different categories, whether it is casting, forming, joining, machining. Like in machining we are getting drilling, turning, milling, grinding, so all comes under the machining. In all those processes removal of material is involved. So first option is correct. Easier communication. If we have classified the manufacturing processes into different categories, then it will be helpful if we communicate to any to the other person. If we since definition of machining is material removal process. If I tell you there is a process, let's say named honing. If I will tell you this honing process comes under machining, you will easily understand there must be some removal of material will be happening in the honing process. So you can easily understand that the what will be typically would have been happening in that process. That's why it will be easier to communicate if we classify the manufacturing processes into different categories. And better understanding of each process, again it is the superset of above two problems. If we understand the processes, then only we will able to classify it into the different categories, like based on the fundamental, or it will be helpful to easy to communicate if and if only we will able to classify it in different categories based on the fundamentals of the process. Then it will also be easy to communicate. We can able to do only if we understand the process very well. So this option is also correct. So correct answer for this problem will be fourth, all of these. So that was the last question for the today's session, although it has extended a little, not little, it has been extended by 50 minutes. So hopefully I am clear to all of you. If you have doubt, if you want to give some feedback or suggestion, please unmute yourself and tell so that I could incorporate those suggestions in the next session, or you can write it in the chat box. So it will be helpful for me to uh, create contents in for the next session. I think this thing will definitely help you. Okay, question number 7. Okay, so let me start from the CAD and CAM. So CAD is added design, CAM and another term is rapid prototyping. Rapid prototyping, here we produce component to check just to check its functionality or let's say properties. Suppose any manufacturing industry is going to launch some new product, then what they will do, first of all, they will survey the market and they will try to understand what is the requirement of the market or the people. Based on that, they will design the product. So how they will do, nowadays design there are different designing softwares like SolidWorks, CATIA, Creo. So many softwares are there where we can make solid models of anything on the computer itself. So if we know this software, then we can easily make a whole design of whole car in the software itself in 3D. So that is known as the computer aided design. So basically we are designing a component or a product with the help of computer. That is part done by that is the CAD. And after CAD, with the help of CAM, we try to manufacture the component with the help of these CAD models. There are many softwares. They can produce the CNC codes. CNC codes are nothing, it's similar to like our programming codes. Basically these codes are the command given to the machine tool which is used to manufacture which is used for manufacturing the component. So from the CAD model, the CAM part is used to produce the codes, CNC codes, which is fed to the machine tool for the manufacturing of the component. We will put raw material in the machine tool and we will give the command CNC codes, and then it will automatically manufacture the component. So this is the CAD and CAM, and rapid prototyping is the something which we just want to see how the product will look like, how what is the aesthetics of the product, how it looks like if it kept on the real environment. So that just we want to check it before the final production. So that is called the prototyping. We will just make a prototype of the component which we want to launch in the market, and we want to see whether it is good or not. So this, if you understood these three terms, then you can understand the why it is correct for the regenerative process and why it is not correct for the forging process. Like forging process, casting process, welding process, there we don't need to design on the CAD on the computer, and we don't have to give any CNC codes to manufacture the component for the forging process, casting process and welding process. But for a regenerative process, it is mandatory. We have to make CAD model, then only we will able to manufacture the component by 3D printing. Without CAD model, we cannot create any component with 3D printing. That's why fourth one is the correct answer. Okay, thank you so much. So I think now it's clear. So any other doubts for any of these questions? Okay, thank you so much, Abhinandan. So if no one has doubt, or you can give any suggestion for the next session, so where how can I improve this session, because still we have to go for the 11 more weeks, so we will be staying together. And if you can suggest something so that we could make this learning process better, please feel free to unmute yourself, or you can write in the chat. Whether I was clear, I was able to make you understand what I wanted to say. It was clear, or the writing part. So if these things are good, or still there were some ambiguity there. Okay. Okay, thank you so much. Okay, so if there are no more doubts, then wish you all a very happy weekend. Please go through the all lectures of the course, and please attend the assignment. And yes, I will wish you all the best to score good in the course and get it certified with very good grades. Okay, thank you so much. Okay, thank you. Okay, then let's end the meeting here itself. Okay, thanks to all.